this chapter? Yesterday we did exponential growth and decay. Thoughts? Once you got going on it, don't forget you have to know the formula for exponential growth, exponential decay, and why is there Jolly Rancher all over my floor? Oh, that child. Exponential growth, exponential decay, and then compound interest. Also, you have to know the exponential formula or exponential function formula, y equals a times b to the power of x. And today I'm going to add geometric sequences. We did arithmetic back in, gosh, chapter 4, I think it was, when it was like, what number? Okay. Are we all done talking and moving? Because I can't even hear myself right now. Yes. Thank you. Okay. Arithmetic sequences are what was our common difference? Remember that? We add 7, add 7, add 7, add 7, or subtract 2, subtract 2, subtract 2. So geometric sequences are when you multiply by the same number over and over. Instead of adding the same number, you multiply by the same number. So here's another formula you have to memorize. A of n equals A of 1 times r to the n minus 1. A of 1 means the first term. Okay? The first term, the first number in that sequence. R stands for the ratio, or what you are multiplying by. The common number that is getting multiplied over and over and over. And we discovered this yesterday. If your R or your base is a negative number or a fraction, make sure you put it in parentheses, correct? And then n minus 1 stays n, because n is what number in the series that you're talking about. Okay? That's why A of 1 here. It is the number that's in the first location. So in this case, let's just start off simple. Write an equation for the nth term. We're not solving anything. If the sequence is -6, 12, -24, 48. The first thing to do is to look and say, what are they multiplying by every time? -2, right? Easiest way to notice that it's a negative, it flip-flops between positive and negative, positive and negative. Okay, so A of n equals A of 1 times r to the n minus 1. A of n stays because you're just saying here's a sequence. What's my first term? -6 times, what's my ratio, or what am I multiplying by? What's going to be important here? Parentheses, because it's a negative, and then n minus 1. There's nothing you can simplify, because technically we'd have to have that exponent before we could multiply. So you're replacing two numbers in there. All right? The first three terms of a geometric sequence are as follows. 5, -20, 80. Find the next two terms of the sequence. Give exact values, not decimal approximations. What are my next two terms? In other words, the next two numbers in this. -160. Okay, you're multiplying times -4, right? So your number would be -320, then 1,280, I believe so. Okay, why would it ever make this statement right here? Do not give decimal approximations. Okay, I'll give you an example. What if I told you 7, 1, 1/7, and I want the next two numbers? What's my common ratio here? Really got to multiply. You got to multiply. You're multiplying. What are you multiplying by? 1/7. You are multiplying by 1/7. Hence, no decimal approximations. They don't want a decimal. What is 1/7 times 1/7? 1/49. And then you would take that times 1/7, which would be 1/343, I think. 343? That's why they're talking about no decimal approximations. Arithmetic sequences, you are adding, arithmetic, adding. Today we're doing geometric, you're multiplying, 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 multiplying. For each sequence, determine whether it's geometric. If it is, find the common ratio. 25, 5, 1/5. No? I think I actually made a typo, if I'm being completely honest. I think there's supposed to be a 1 in there. But the way it's written, no, it's not geometric. 8, 10, 12, 14. What are you multiplying by? It's not a guess. You're multiplying. 8 times what gives you 10? 8 plus 2 gives you 10, right? And plus 2 gives you 12. And plus 2 gives you 14. Is that geometric? No, that's arithmetic. Okay? Part of the reason you guys are so confused is because nobody's fully listening to me and you continue to talk while I teach. It doesn't matter how many times I stop. The next one, 2, -8, 32, -128.
Yes.
What are you multiplying by? Yes, r equals -4. Nicely done. Okay, arithmetic means you're adding something. Geometric, you're multiplying. Oh, crazy. Remember, arithmetic sequences had a common difference that we added to each term. For each sequence, determine whether it appears to be arithmetic, geometric, or neither. 19, 14, 9, and 5. Arithmetic, why?
Because it's subtracting or adding, I guess.
Adding a -5, right? So it's arithmetic. D, or your common difference, was a -5. 49, 64, 81, 100. Neither? What are those?
I don't know, numbers?
They're your perfect squares, right? 7 squared, 8 squared, 9 squared, 10 squared. There is no pattern there. It is neither. Or there is no sequence. It's a pattern, but there's no sequence. 1600, 400, 100, 25.
Yes.
Which one?
Divide by 4.
So geometric. R is, and I like your guys' interchange of that actually, dividing by 4 is really the same as multiplying times 1/4. Nicely done. Multiplying by 1/4. Okay, we're going to have to dig back in our brain cells here. The sequences below are either arithmetic or geometric, so they're telling you they're a sequence. For each sequence, determine whether it is arithmetic or geometric, and then write the formula. Off to the side. Geometric, that's from the front of this worksheet. A of n equals A of 1 times r to the n minus 1. But remind yourself, arithmetic. A of n equals A of 1 plus d times n minus 1. In both of these, you got to replace the first term and then the ratio or the common difference. Okay? 6, 30, 150. Geometric. And 5, write the formula. Don't say it out loud. Geometric, write the formula for me. A of n equals 6 times 5 to the n minus 1. Does 5, excuse me, need parentheses? Technically, no. Is it going to count it wrong if you put them on there? No, so it may be something just to get in the habit of putting them in there. 17, 20, 23. Arithmetic. On your own, fill that one out. This is going to take you way back, so now I have the hiccups. A of n equals 17 plus 3 parenthesis n minus 1. Do you have to distribute and combine like terms? What if your common difference was negative? And so instead of plus 3, it would be a minus whatever the case is. Okay? All right. Last one, and then I'm going to turn you loose. Find the sixth term of the geometric sequence whose common ratio is a half and whose first term is 8. Do not sit and write this sequence out. Use the formula. A of n equals a of 1 times r to the n minus 1. What's my first term? 8. What's my common ratio? 1/2. What number in the sequence do they want? 6. Where is 6 going in for? N. So we have 8 times 1/2 to the 6 minus 1. What should I do first? 6 minus 1, which is 5. Now what should I do? 1/2 to the 5th, which really means 1 to the 5th and 2 to the 5th, yes? 1 to the 5th is, don't you dare pick your calculators up. You need 5 of them. 2 times 2 times 2. Start over. Don't shout out loud. Don't shout random things. 2 times 2 times 2 times 2 times 2. 32. 1/32. Now what do I do? You're going to multiply. How am I going to multiply? Straight across. Straight across. What am I going to do to my 8 first? Put it over 1. Before you multiply, you know what I do? Cross simplify. What goes into 8 and 32? 8 would become a, 32 would become a, now I multiply across. What is the sixth term? 1/4. Now, do I know you could sit there and write it out? Yeah, but if I ask you for the 22nd term, nobody wants to write out 22 terms. Agreed? Look at me. Look at me. My patience with this class and the chattiness is gone. Some of you are frustrated just as much as I am because people don't shut up. If I have to ask you to stop talking, you will spend time with me after school today. I'm done with it. I don't give you work time for you to have social hour. Do that after 3:10. Got it? Get your scratch paper. Go to work.